Hello everybody, my name is Tomek Wróbel from Arkansas, and this is hopefully the first episode on this show. The thing I want to talk about to you today is contract tests in evented systems. So let me just introduce the idea of contract tests. Let's say you have a situation where you have two API services in your system, and one of them at some point makes a particular HTTP call to the other one, and you cannot, for some reason, make a full end-to-end test for this situation. So what you would do is to have two tests, one for the first service and the other for the second service. In the first one, you would just see if your service call makes a particular HTTP request with a particular structure, query string, params, headers, and so on. And in the other one, you would make the test with hopefully the same data and see if it does what it should do. But then comes the question, how do you ensure that these two request structures are the same? Because if they are not, then you're testing the wrong thing. So, for this particular situation with HTTP requests, there are even full-blown solutions like, for example, packed GEM, which does a lot for you, like stubbing requests and so on. But this problem of contracts between layers happens in many places of our systems, for example, with unit tests and stuff. And in our case with evented systems, because of the fact that events make such a good interface between components, we often tend to write tests that, for example, test if a particular command handler, given some command, outputs some event or some set of events. And then we can have a read model test that gets as input some set of events, and then it checks whether the read model is in a particular shape. So here also comes the question, how do you ensure that these two are in sync and test the real situation? So with events, it seems like this is something you can get for free, because you can either instantiate an event, let's say in a strict mode, where in case that you put the wrong data in your payload, it will fail, or you can do it in a, let's say, elastic, flexible mode where you just accept any data in the payload. In case of race event store, we don't regulate this approach, and currently you don't have to specify schemas for events, but if you do and make some validations before instantiating an event, then you can effectively achieve a contract with this particular event, because let's say before publishing an event in an aggregate, you just validate whether it satisfies a particular schema. Let's say that the first attribute is a string and the other is an UID, and maybe there's a number and so on. And then on the other side, where you test your read model, you use the same event definition with the same schema. You will have it validated on the input whether these two match. So this is one of the things that you can get for free when building your systems around events. So how you do it in your system? It of course depends on the serialization method that you use. In Race Event Store, we by default use the YAML serialization, because this is the default in the Ruby world, and there's nothing that forces you to have a particular schema, because it's kind of defined inside the payload. But you can just check the payload in your constructor. But if you used a different serialization method like protobuf, it relies on having a particular schema, so there you couldn't even do it without. So it all depends on what kind of serialization you use. Okay, so that's it, what I wanted to talk to you today. Thank you very much for listening, and have a good day.